Chalo, good evening, all of you. So let us start the MCQs from basics of motion. That is, we have started last time. Okay. So see here, the question number 20. Okay, just read it once. See, if a car moving with a velocity of 10 meter per second can be stopped by the application of a constant force F in a distance of 20 meter, then if the velocity of car would be 30 meter per second, then it can be stopped by this force in what distance? That is to be found out. So see here, it's very simple. Yes. Okay. So basically, the car moving with the velocity 10 meter per second can be stopped in a distance of 20 meter. तो देखो इसमें यहाँ पे जो कार का जो वेलोसिटी है, इनिशियल वेलोसिटी, तो वो अगर 10 मीटर पर सेकेंड रहा तो उसको स्टॉप करने के लिए 20 मीटर डिस्टेंस ट्रेवल करना पड़ता है. करेक्ट है. 20 मीटर डिस्टेंस ट्रेवल करने के बाद वो स्टॉप होता है. तो अगर उसका वेलोसिटी, इनिशियल वेलोसिटी, वो अगर 30 मीटर पर सेकेंड रहता है तो ऐसे हालत में ये बॉडी जो है वो उसी कांस्टेंट फोर्स के चलते कितने डिस्टेंस में वो स्टॉप किया जाएगा. तो देखो दोनों सिचुएशंस में एक बात तो क्लियर है, u का वैल्यू दिया हुआ है, ठीक है, u इज गिवन हियर एंड v इज गोइंग टू बी 0 कंपल्सरीली. करेक्ट है. सो इफ यू अप्लाई एंड द डिस्टेंस हियर इज गोइंग टू बी 20, right? So if you apply the third kinematic equation which we have already, that is v square is equal to u square plus 2as, right? तो v के बदले आप आ जाएगा 0, तो 0 square becomes equal to u. U is actually going to be 10 meter per second, so you can replace it by that and get this 10 का square जो बनता है 100 plus 2 times of a which is not known and s is already known to be 20 meter here. So this 20 can be replaced here so as to get this acceleration. How much this acceleration is going to be? See here, 0 is equal to 100 plus 40a, which gives 40a is equal to minus of 100, which means a must be equal to minus of 100 by 40, which is actually going to be 20 से अगर reduce करेंगे ना इसको तो 22s are 25s are, so it's going to be minus of 5 by 2. Okay, that is acceleration. Okay, now we'll use this third kinematic equation once again in the second situation that is to be found out. तो अभी यहाँ पे सेकेंड सिचुएशन के अंदर क्या है ना, 30 मीटर पर सेकेंड इसका इनिशियल वेलोसिटी है, मतलब u is given to be 30 this time and v is again 0 because we want to stop this car and the distance traveled is to be found out, and since the force is same, देखो same constant force बोला है ना उन्होंने, तो if application of the constant force और यहाँ पे बोला है कि stopped by the same force, तो इसका मतलब force same है, तो force same होने से क्या होगा, acceleration भी same होगा, और acceleration same होने की वजह से हम यही acceleration जो यहाँ पे हमने निकाला हुआ है तो वो यहाँ पे भी यूज कर सकते हैं आराम से, no problem, and then we can just be find out. So here v becomes 0 and hence it becomes 0 square, which is going to be equal to u square. U is nothing but 30, so 30 का square plus 2 times of a which is minus of 5 by 2 into s, that is the displacement that is to be found out. So if we use this and simplify this further, then we can get this 0 is equal to 900 minus, what is this, 2 cancel and we are left with minus 5s, right? So ये 5s, if we take this 5s in that side, then we get this 5s is equal to 900, which gives s is equal to 900 upon 5. And what is 900 upon 5? We know that it is going to be 5 ones are and 5 8s are, तो 180 बनता है, 180. see here. So 180 meter, this is going to be the distance which will the second time when the car is traveling with the velocity 30 meter per second, it will require 180 meters to travel before it stops, no doubt. Then again 21, the displacement of the particle is given by y is equal to a plus bt plus ct square minus dt raised to 4, right? Then the initial velocity of and acceleration of the car respectively. Okay, that means we want to find out the initial velocity as well as acceleration also, right? So how can we get that? Initial velocity, देखो y is equal to a plus bt plus ct square minus dt raised to 4, correct है? So if we differentiate this with respect to time, dy by dt अगर हम निकालेंगे तो इससे हमको velocity मिलेगा, जो बनेगा अभी a का डेरिवेटिव 0 प्लस bt का डेरिवेटिव b into 1 obviously plus c into t square का डेरिवेटिव which is 2t and minus d into t raised to 4 का डेरिवेटिव which is 4t cube, correct है? Yes. Now this is going to be actually the velocity which is going to be b plus 2ct minus 4dt cube. Okay, so this is the velocity, but we want initial velocity. Just check here. So in order to find out the initial velocity, we will have to put this t equal to 0 here in this equation, so that we get this initial velocity, that is v naught, which is actually going to be b plus 0 plus 0, which is actually going to be b only. So initial velocity is found out to be b meter per seconds. Okay, and the acceleration, initial acceleration is also to be found out. So how will you get that? Just differentiate this equation once again. So इस equation को फिर से differentiate कर दो फटाफट. So if we do that, we get this dv by dt, which is going to be b का derivative 0 plus 2c is a constant out and t का derivative 1 minus 4d is again a constant out and t cube का derivative बनता है 3 into t square, बराबर? So that we can get this as a acceleration of the particle, and hence we can write that a is equal to 2c minus 12d t square, correct है? This is equation for acceleration, but again put this t equal to 0 here because we want initial acceleration. So we get initial acceleration simply 2c, because this term is going to get vanished because t is going to be 0. So we find that the acceleration is going to be 2c and velocity, initial velocity is going to be simply b. So b and 2c must be the answer. Check. It is available in option number B here, C here. Okay, so C is the correct option. B and 2C. That's all. Okay. Next, 22nd. The displacement of the particle is given by x equal to 2t square plus t plus 5. Okay, तो displacement का equation जो है वो दिया हुआ है, बराबर? चलो ठीक है. So if displacement is given to be x is equal to 2t square plus t plus 5. Okay, then what? The acceleration of the particle at t equal to 2 seconds is, acceleration के लिए इसको हमको differentiate करना होगा. अभी मैं डायरेक्ट करता हूँ फटाफट. 2 into 2t becomes 4t plus 1, correct है? ये हो गया velocity. And if you find out acceleration, just differentiate this once again and we get this 4, and that is going to be the final answer, which is already there in the option number A here. That is 4. चलो ठीक है. Next one. Yes, the train traveling on a same track are approaching each other with equal speeds of 40 meters per second. The drivers of the train begin to deaccelerate simultaneously when they are just 2 kilometers apart, assuming the deaccelerations to be uniform and equal. Okay, deaccelerations are equal. Okay, the value of deacceleration to barely avoid collision should be. अब देखो ये एक इंटरेस्टिंग क्वेश्चन है, हम ये सॉल्व कर सकते हैं आराम से. देखो ठीक से, the two trains traveling on the same track and are approaching each other with the equal speeds of 40 meters per second. Okay, so consider this as a common track, and this is the first train which is moving this way with the speed of 40 meter per second, and another train which is moving in the opposite direction with the speed of 40 meter per second. Okay, so and they are just 2 kilometers apart. That means the distance between them is already given, which is 2000 meter. समझा कैसे? Because already the velocity is given in meter per second, so we will have to take the distance in also meter. So इसलिए यहाँ पे 2000 मीटर ये हो गया उनके बीच में का डिस्टेंस. चलो ठीक है. अभी assuming the deaccelerations to be uniform and equal, इसका भी deacceleration equal है और इसका भी deacceleration उतना ही है. That means जब दोनों का initial velocity भी same है और deacceleration भी same है, तो obviously उनके दोनों के द्वारा distance भी equal travel किया जाएगा. ठीक है ना? और हमको क्या करना है कि उनको collision नहीं होने देना है. ठीक है, इनका just collision होने से बचना चाहिए. So that means both of these trains must just arrive at this point here, which is the middle point of the both of the trains. मतलब इन दोनों के बीच में जो distance है उसके मिड पॉइंट पे ये दोनों ट्रेन्स आके रुकनी चाहिए ताकि कोलिजन ना हो. और अभी कोलिजन न होने के लिए फिर इस ट्रेन को, फर्स्ट वाली ट्रेन को कितना डिस्टेंस ट्रैवल करना पड़ेगा? ऑब्वियसली 1000 मीटर डिस्टेंस ट्रैवल करना पड़ेगा, राइट? एंड ऑब्वियसली सेकंड वाली ट्रेन को भी उतना ही, मतलब 1000 मीटर डिस्टेंस ट्रैवल करना पड़ेगा क्योंकि इन दोनों के इनिशियल वेलोसिटीज भी सेम है और इनिशियल एक्सेलरेशंस भी सेम है, कांस्टेंट है. तो इसलिए अभी ये हमको, हमारा जॉब अभी ये है कि वी हैव टू फाइंड आउट द acceleration, value of acceleration, which will make this train travel a distance of 1000 meter before it stops, when it is already moving with a velocity of 40 meter per second, and that can be done by third kinematical equation simply, which we have already done in the previous example. तो अभी देखो v square is equal to u square plus 2as. ये अगर हम यूज करेंगे तो यहाँ पे v कितना चाहिए हमको? यहाँ पे जाने के बाद ट्रेन रुकना चाहिए कि नहीं? तो इसलिए v must be 0. तो 0 square happens to be u square, where u is going to be 40 here for each of the train. So any one train we can consider here. So here it is going to be 40 square plus 2 times of acceleration that is to be found out, and distance is given to be 1000 meter. Correct hai? So if you simplify this further, then we get this 0 is equal to 1600 plus 2000 a. Correct hai? And if we take this 2000 a in this side, then we get this, yes, so 2000 a is going to be actually 1600, and hence a becomes actually equal to 1600 upon 2000, and two zeros can be just cancelled and this can be reduced by 2. तो अगर इसको 2 से reduce करेंगे तो 2 8s are, and here it will be 2 10s are. And what is 8 upon 10? 8 upon 10 मतलब 0.8, okay, meter per second square. So 0.8 meter per second square should be the acceleration of both of these trains, so that they can be barely avoided from the collision. Okay, the body moves from the rest with a constant acceleration of 5 meter per second square. Its instantaneous speed at the end of 10 seconds is, just we can find out it using the kinematical equation. Which kinematical equation will be useful here? Yes, type it in the chat box. Which kinematical equation we will use here? A body moves from rest with a constant acceleration of 5 meter per second square. Its instantaneous speed in the at the end of 10 meter per second. Very good. First kinematical equation will be used. Karo use फिर फटाफट. Do it orally. Its initial velocity is already going to be 0, right? Because it starts from rest. So v equal to u plus at, where u is going to be 0 and a is going to be 5 and t is going to be 10. So 5 into 10 becomes 50. That is going to be the final velocity. That's it. We have done it orally. Okay. Chalo, next one. 25th one. The acceleration a in meter per second square of the particle given by a is equal to, yes, this is again one of the important questions. See here, the acceleration of the body is given to be 3t square plus 2t plus 2. Okay, acceleration is given here. and t is the time. If the particle starts out with the velocity u equal to 2 meter per seconds at the time t equal to 0, so initial velocity कितना है particle का 2 meter per second है, ठीक है. Then the velocity at the end of 2 seconds is, okay, here is the case we can understand that we are not to use the kinematic equations here. Why? Because acceleration itself is a variable, okay, acceleration is not a constant, so we are not to use the kinematic equations. Kinematic equations are not of use in anywhere here. So what we have to do then, so what here we have to use the differential forms. तो acceleration का definition क्या होता है, हमको पता है, it is dv by dt, correct है, dv by dt. If we replace this value of acceleration here, then we can get the value of acceleration dv by dt as it is, which is going to be, here it is going to be 3t square plus 2t plus 2, correct है. And then we can just transfer this dt in this other side so as to get dv is equal to 3t square plus 2t plus 2, correct है. And then we have to into dt, okay, and then we have to integrate this equation actually. So if we integrate this dv here, then we can get integration of 3t square plus 2t plus 2 also into dt as it is, so that and we can get this, and plus c also, plus c क्यों, क्योंकि it's a constant of integration. Remember, whenever we integrate the equation we get a constant of integration. Yes, so that's why this plus c will appear here. And then in the next step we can have this integration of dv to be simply v, which is going to be, yes, तो 3t square का इंटीग्रेशन क्या होगा, देखो ठीक से, 3 is constant and t square का इंटीग्रेशन बनेगा t cube upon 3 according to the formula for integration, that is integration of x raised to n is nothing but x raised to n plus 1 upon n plus 1, करेक्ट है. तो ये फॉर्मूला के हिसाब से यहाँ पे t square का इंटीग्रेशन क्या बनेगा, t raised to 2 plus 1 upon 2 plus 1, मतलब t cube upon 3, okay, plus what is the integration of this 2t here, 2 is a constant out and t का integration बनता है t square upon 2, once again according to the same formula here, that is t का है ना, तो t का integration क्या बनेगा, t मतलब t raised to 1, तो t raised to 1 का integration बनता है t square upon 2, t raised to 1 plus 1 upon 1 plus 1, okay, plus here this is 2 here, so 2 is a constant, can be taken out, but what is the integration of this dt only, is dt का integration क्या बनेगा, it's going to be t, and that's why we are left with this t here, okay, and plus c as the constant of integration kept as it is, okay. But just read this question again once again and see there is one another information given here, is that the particle starts out with the velocity of 2 meter per second at time t equal to 0. That means the velocity of particle is given to be 2 meter per second when time t was 0. So we can use these values here. That means when time t becomes equal to 0, the velocity v is going to be 2. That is we have to understand. देखो यहाँ पे, ठीक है, we have to use that when t is going to be equal to 0, u or v is given to be 2. जब t का वैल्यू 0 था तो उस समय v का वैल्यू कितना था, 2 था. तो ये हमको यहाँ पे दिया हुआ है, देखो ठीक से, okay, and we have to make use of this fact here in this equation so as to find out this c, okay. तो just put this value v as 0 and जिधर भी हमको t दिखता है तो इस t के बदले क्या करना है, 0 डालना है, और v के बदले क्या डालना है, ये 2 डालना है, ठीक है. तो let us do that. So you get this as 2 is equal to, अच्छा ये 3 तो चलो कैंसिल हो जाएगा, even this 2 also will get cancelled and we'll left with t cube. What is t cube here, it is 0 cube, which is 0 only, plus 0 square, which is 0 again, plus 2 into 0 again, which is 0 again, plus c only. That means 2 becomes equal to c, which means c becomes equal to 2, okay. c का वैल्यू ही हमको मिल गया, that is going to be 2, okay. And once we get the value of c, now we can just find out the value of v here. अभी इस इक्वेशन को अगर हम थोड़ा रीअरेंज करेंगे तो देखो लिख सकेंगे v is equal to, अच्छा 3 कैंसिल होने के बाद बचता क्या है, सिंपली t क्यूब प्लस here t स्क्वायर, ओके, प्लस 2t प्लस c, ये इक्वेशन v का था, but already we have found that c is going to be equal to 2, right, from the given information. So if we use this value of c here as 2, then we can get the next step, that is v is equal to t cube plus t square plus 2t plus 2, correct है? This is the velocity in general at time t, but just check what we have to find out, that the velocity at the end of 2 seconds is, okay, तो time t equal to 2 seconds हमको लेना है और velocity निकाल के दिखाना है, तो just put t equal to 2 here in this equation so as to get the velocity at 2 seconds. So it becomes 2 का cube plus 2 का square plus 2 times of 2 plus 2 again, which is going to be 8 plus 4 plus 4 plus 2, which happens to be 8 plus 8, 16 plus 2, 18. So 18 meter per second. This is actually going to be the velocity. Yes, which is already there in this option number B here. Okay. So here we are going to see the use of acceleration here. जो acceleration का जो use है, तो वो हमको यहाँ पे पता चल रहा है. चलो ठीक है. What does it work out this 26th one? A particle moves along the straight line such that its displacement at any time is given by s is equal to t cube minus 6t square plus 3t plus 4 meter. Then the velocity of when acceleration is 0 is also one of the important question. See here, we want to find out the velocity, but velocity कब निकालना है हमको, कौन से इंस्टेंट पे निकालना है, जब एक्सेलरेशन 0 बनता है. तो वो इंस्टेंट डायरेक्ट दिया नहीं है, वो इनडायरेक्टली दिया हुआ है. वो हमको निकालना होगा कि एक्सेलरेशन कभी 0 बनता है, और जिस इंस्टेंट पे एक्सेलरेशन 0 बनता है, उस इंस्टेंट पे वेलोसिटी कितना है वो हमको ढूंढ कर निकालना है. तो देखो, s is actually given to be s is going to be t cube minus 6t square plus 3t plus 4. Okay, so find out the expression for velocity immediately. Just find it out orally. Differentiate this equation. 3t cube का डेरिवेटिव 3t square minus 6t square का डेरिवेटिव 12t, करेक्ट है ना, प्लस 3t, 3t का डेरिवेटिव simply 3 and 4 का डेरिवेटिव 0, no need to write at all. And then again acceleration, find out the acceleration. Just differentiate this once again. 3 into t square का डेरिवेटिव 2t, जो 3 into 2t कितना बनता है, 6t बनता है, माइनस 12t का डेरिवेटिव 12 and 3 का डेरिवेटिव 0, अगेन नो नीड टू राइट. तो देखो, दो स्टेप में हमने वेलोसिटी भी निकाल लिया और एक्सेलरेशन भी निकाल लिया. ओके, अभी हमको क्या करना है, व्हेन एक्सेलरेशन इज 0, वी हैव टू फाइंड आउट द इंस्टेंट व्हेन एक्सेलरेशन बिकम्स 0. सो एक्सेलरेशन 0 कब बनता है वो निकालने के लिए हमको a equal to 0 पुट करना पड़ेगा. a equal to 0 is to be put in equation number 2. So what we get is 0 is equal to 60 minus 12, which gives 60 is equal to 12, which gives t is equal to 2. Okay, so we got an instant when acceleration becomes equal to 0. At time t equal to 2 seconds, the acceleration is going to become 0. So put this value of time 2 here in equation number 1 so as to get the velocity at that instant where acceleration becomes equal to 0. So if you put this t equal to 2 here in this equation, then we can get v is equal to 3 times of t square. तो मतलब 3 times of 2 का square हो गया वो, minus 12 times of 2 plus 3 as it is. So that this v actually becomes equal to 3 into 4, okay, which is 12, minus 12 into 2, which is 24, and 3 as it is. So that v becomes actually equal to 12 minus 24 plus 3 comes out to be 12 minus 24 is minus 12, and minus 12 plus 3 comes out to be minus 9. So minus 9 meter per second. This is going to be the final answer. Check, it's there in option D here. Okay, तो D option में हमको पता चल रहा है कि -9 मीटर पर सेकेंड है. So this is the velocity when the acceleration becomes equal to 0. Basically time t equal to 2 seconds पे acceleration 0 बनता है. इसलिए हमने velocity के equation में time t equal to 2 डाल दिया, जिससे ही हमको वो velocity मिल गया उस instant पे, जिस instant पे acceleration 0 बनता है. चलो ठीक है. Let us see the next one. X and y are the coordinates of the particle at time t given by x is equal to 7t plus 4t square, okay, and y is also given to be 5t, okay, and x and y are in meters and t is in seconds. Then the acceleration of the particle at t equal to 5 seconds is, yes, how will you get the acceleration? See here, so first of all we have to differentiate this dx by dt निकालना है हमको, जिससे हमको क्या मिलेगा 7 plus 8t, which you can call it as a vx, okay, velocity का horizontal component और x component उसको हम बोल सकते हैं. It is going to be 7 plus 8t, okay. In the same way here, find out dy by dt also. And what is dy by dt here? It is 5. But what is dy by dt called? It's called the y component of velocity, which is denoted by vy, and that is actually going to be 5. चलो ठीक है, vx मिल गया, vy मिल गया, okay. But also find out the acceleration here. Acceleration कैसे निकालेंगे? Just even differentiate this vx also. So if we just differentiate this dvx by dt, तो इस vx को अगर हम differentiate करेंगे तो मिलता क्या है हमको 7 का डेरिवेटिव 0 plus 8t का डेरिवेटिव simply 8, correct है? That is going to be the x component of acceleration, that is going to be 8, okay. And at the same time this dvy by dt, find out that. Means we have to differentiate this vy also with respect to time, so as to get it as 0, and hence you can say that the y component of acceleration is going to be 0. But since we want to find out the net acceleration at time t equal to 5, so we will just take this a to be equal to root of ax square plus ay square, which is the ready-made formula we have already. So we get this as root of 8 का square plus 0 का square. तो अभी 8 का स्क्वायर करेंगे तो कितना आएगा 64 आएगा, और 64 का रूट निकालेंगे तो कितना आएगा ऑब्वियसली 8 ही आएगा वापस. तो इसलिए एक्सेलरेशन इज एक्चुअली गोइंग टू बी 8 मीटर पर सेकंड स्क्वायर, ओके. Actually this is a special case where acceleration is a constant, and that's why we are going to get the acceleration at 8 meter per second square, and we need not to put this time t equal to 5 in this case here. यहाँ पे हमको किधर भी t equal to 5 पुट करना नहीं पड़ा, क्योंकि एक्सेलरेशन इज कांस्टेंट थ्रू आउट. तो जो एक्सेलरेशन कांस्टेंट है तो वो टाइम t इक्वल टू 5 के लिए भी उतना ही रहेगा ना. इवन टाइम का कोई भी वैल्यू दिया रहता तभी भी एक्सेलरेशन उतना ही आना था, तो यहाँ पे एक्सेलरेशन कांस्टेंट है. चलो ठीक है. बट वन मोर थिंग इज दैट वी कैन आल्सो सॉल्व दिस इक्वेशन बाय अनदर मेथड. देखो ठीक से एक दूसरा मेथड भी हमारे पास है जिससे हम ये सॉल्व कर सकते हैं इक्वेशन. देखो कैसे. If we just compare these two equations with the second kinematical equation here, तो अगर हम second kinematical equation के साथ इसको अगर कंपेयर करेंगे, जो कि हमारे पास है ऑलरेडी, s इज इक्वल टू क्या होता है ut प्लस हाफ a t स्क्वायर, करेक्ट है. इसको अगर हम कंपेयर करेंगे इसके साथ तो हमको मिलता है s इज इक्वल टू x, और ये u जो है इनिशियल वेलोसिटी इज गोइंग टू बिकम 7, and if we equate this half a with this 4 here, then we get this half of a ax actually, ax, क्यों? क्योंकि इट्स अ x कोऑर्डिनेट हियर. सो यहाँ पे क्या होना चाहिए x कंपोनेंट ऑफ एक्सेलरेशन होना चाहिए, जो बनेगा 4. तो अगर हाफ x को अगर 4 लिख देंगे तो इससे हमको क्या मिलेगा ax इज इक्वल टू 8. दैट्स व्हाट वी हैव गॉट इट. एंड सेकंड किनेमेटिक यहाँ पे ये जो हम देख रहे हैं कि यहाँ पे t स्क्वायर वाला टर्म है ही नहीं, t स्क्वायर वाला टर्म ही नहीं है. और जब जिस इक्वेशन के अंदर डिस्प्लेसमेंट के इक्वेशन में अगर t स्क्वायर वाला टर्म ही नहीं होता है तो इट्स अ यूनिफॉर्म मोशन, एंड यूनिफॉर्म मोशन होने की वजह से the acceleration यहाँ पे 0 आ जाएगा. So you can say that the acceleration y component of acceleration is going to be 0. And even if we equate this with this second kinematic equation here, then we can get this ut term equated with this 5t, so as to get u equal to 5, no doubt. But here a half at square वाला जो टर्म है वो यहाँ पे है ही नहीं, तो इसलिए फिर इसको हमको 0 के साथ इक्वेट करना पड़ेगा, जिससे हमको एक्सेलरेशन भी 0 मिल जाएगा, and that's what we want to say here. So ay is going to be 0 and ax is going to be 8. So the net acceleration will be same as this x component of the acceleration, because y component of acceleration is going to be already 0. So that's why we can get this a equal to 8 in this case from other method also, which is already available there in option number B here. Okay, yes. So next one. Let's try this 28th one. Engine of a car produces acceleration of 4 meter per second square. Okay, in the car, if the car pulls another car of same mass, what will be the acceleration produced? Yes, देखो अगर एक कार है, एक कार, उसका इंजन उस कार के अंदर 4 मीटर पर सेकेंड स्क्वायर इतना एक्सेलरेशन प्रोड्यूस करता है. एक्सेलरेशन इक्वल टू क्या होता है? द फोर्स डेवलप्ड बाय इंजन अपॉन द मास ऑफ द कार. ओके, but abhi in the second situation, what is they have said here is we have to pull another car of same mass. तो इसका मतलब अभी देखो एक ही इंजन है और दो दो कार हमने लगा दिए एक के पीछे एक, तो ऐसे इसका मतलब क्या हो गया कि mass has been doubled. So in that case, the new acceleration here in this case will be the same force of engine F divided by the double mass. But already we know that this F upon m is nothing but a, right? So if you replace it by that, then we can get this as half of a. That means the acceleration is going to get halved. So that means if suppose initially the car engine can produce the acceleration of 4 meter per second square in a single car, then if another similar car is applied to it, and if that engine has to pull the two cars, that means the acceleration will just get halved. हार्ड मतलब ये 4 का आधा हो जाएगा एक्सेलरेशन, मतलब 2 मीटर पर सेकेंड स्क्वायर हो जाएगा सीधा, which is already there in the option number B here. Okay, yes. 29th, a body starts from rest and travels 120 centimeter in 6 seconds. Then what is the acceleration? We can find out orally. See, the body travels 120 meter distance in 6 seconds and starts from rest. Starts from rest means u must be 0. एंड टाइम t इक्वल टू 6 सेकंड के बाद क्या होता है, उसका वेलोसिटी सॉरी उसका जो डिस्टेंस है वो 120 मीटर बनता है. सो जस्ट यूज दिस ऑल वैल्यूज हियर इन द इक्वेशन, सेकंड काइनेमेटिक इक्वेशन, दैट इज s इक्वल टू ut प्लस हाफ a t स्क्वायर. सो दैट वी गेट दिस s इक्वल टू 120, u is 0, half a is to be found out, t is 6, so 6 का स्क्वायर which is 36, so 120 is equal to 1 by 2a into 36, so that this 2 ones are 2 18s are, hence we get this 120 equal to 18a, means a must be equal to 120 by 18, so that this can be reduced by 6 here. So 6 3s are and 6 2s are, so 20, so it's going to be 20 by 3 मीटर पर सेकेंड स्क्वायर. इट्स वेरी सिंपल. ओके, सो 20 by 3 मतलब कितना हो गया वो, अच्छा सेंटीमीटर. ओके 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 ओके, सेंटीमीटर दिया हुआ है, सेंटीमीटर, डोंट फॉरगेट द यूनिट, सेंटीमीटर. सो सेंटीमीटर मतलब क्या हो गया, ये 120 सेंटीमीटर है ना, तो उसको कन्वर्ट करना है मीटर में, जिससे वो बन जाएगा सिंपली 1.2 मीटर. ओके, so here it is 1.2 meter. So if we put this 1.2 here, then 1.2 here also, so the answer will be, तो देखो अगर 6 से डिवाइड करेंगे तो 6 3s are and 6 0.2s are, correct है, so it's going to be 0.2 here like this. Okay, so 0.2 divided by 3, which can be supposed to be 0.2 upon 3, कितना होता है 0.06 6, 7. It might be some mistake in the question itself. Okay, the mistake is that we want to find out the actually what is given here is, see, if we just read it carefully, then the body starts from rest and it travels a distance 120 centimeter in 6th second. ऐसा है वो, ठीक है, 6th second. ओके, वो टीएच जो है वो बहुत छोटा हो गया है, ये देखो टीएच 6th second, मतलब सिर्फ 6th second में उसने 120 सेंटीमीटर इतना डिस्टेंस ट्रैवल किया है. ओके, that is going to be the actual question. So then it will just be solved by a different formula. तो अभी यहाँ पे हमको दूसरा फॉर्मूला यूज करना पड़ेगा. देखो ठीक से कौन सा फॉर्मूला यूज करना है अभी यहाँ पे. what is the formula for finding the distance traveled in nth second? We have just derived it last time. If you remember, last time हमने ये फॉर्मूला डिराइव किया था. The distance traveled in nth second. What is it? It is Sn is equal to u plus half into a into 2n minus 1. You remember? So this Sn is given here. Okay, and this n is going to be equal to 6 here. So S6 will actually be equal to u plus half a into 2 into 6 minus 1, correct hai? Which gives, and S6 is actually given to be this 120 centimeter here, which is nothing but 1.2 meter. So you can just replace it by that. 1.2 is equal to u, which is rest matlab 0, plus half of a, which is to be found out, and 2 into 6 means 12. 12 minus 1, which is going to be 11. So that we get this 1.2 equal to 11 by 2a, which gives, ये 2 अगर इस तरफ लेके जाओ तो वो 1.2 into 2 बनता है 2.4. So 2.4 divided by 11, which is going to be a here. So the acceleration of the body will actually be equal to 2.4 upon 11. Now this can be done easily. So 11 ones are and 11 zeros are and 24 हो गया, तो 11 twos are 22 and 2 बचा 20 हो गया. Again it will be 11 0.1 जा 2 1 जा, और कितना बचा अभी 20 में से 11 गया तो 9 बचा. 9 मतलब 90 हो गया वो, तो इसलिए वो 11 8 जा 88. So it's going to be 0.218 meter per second squared, which is there in option number C here. Check. Okay, let us see this 30th question. A car at rest accelerates uniformly to the speed of 144 km per hour in 20 seconds. Then it covers a distance of, yes, which kinematical equation can you use here? Just tell me fast. Which kinematical equation we will use here? कौन बताएगा? देखो, accelerates uniformly, car at rest मतलब u is going to be 0, right? Uniformly to the speed of 144 km per hour, मतलब v is actually given to be 144 km per hour. No doubt we have to convert this in meter per second, and one more thing is given here is the 20 seconds. That means time is also given here, time t equal to 20 seconds. Which kinematical equation used to be used here? थर्ड में बेटा हाँ डिस्टेंस निकालना है ना हमको, but acceleration is not given already. So first of all, we'll have to find out the acceleration here. What is acceleration? V minus u upon t, which is going to be, अच्छा but सेकेंड का कोई यूज ही नहीं यहाँ पे. सेकेंड के लिए हमको ut plus half at square. Yes, once we find out a, we can use either first or third, no problem. But a तो find करना पड़ेगा ना पहले. And there is another technique to find out the distance directly without finding a. That is the fourth kinematical equation. If you remember, I have already given 3 kinematical equations, and उसके बाद नीचे एक supporting में और एक equation हमने बनाया था. If you remember, तो वो हमने बनाया था s is equal to, actually वो बना हुआ ही है, तो वो actually u plus v upon 2 into t. This can be regarded as a fourth kinematical equation, because whenever all these 3 kinematical equation cannot be used because of the lack of acceleration, then we can use this fourth one. Okay, if we have not given the acceleration here, then in that case we have to use this s equal to u plus v by 2 into t. Actually this is the starting point of the derivation to prove the second kinematical equation. Second kinematical equation जो है आता ही कहाँ से है? इस इक्वेशन को सॉल्व करने के बाद ही वो आता है. इसको सिंप्लीफाई करने के बाद ही सेकंड किनेमेटिक इक्वेशन बनता है. इसमें हमको v इक्वल टू u प्लस at रिप्लेस करना होता है, फिर उसके बाद सिंप्लीफाई होकर वो हमारा नॉर्मल सेकंड किनेमेटिक इक्वेशन बनता है. ठीक है, तो अगर यहाँ पे हम ये यूज करेंगे तो फायदा ये है कि इसमें एक्सेलरेशन निकालने की जरूरत नहीं पड़ेगी. अदरवाइज आइदर वील हैव टू फाइंड आउट द फर्स्ट ऑफ ऑल वी विल हैव टू फाइंड आउट द एक्सेलरेशन, and then we can use either first or third kinematic equation so as to get the displacement. But if we use this equation directly, then we will not require to find the acceleration. So acceleration find करने की जरूरत नहीं पड़ेगी हमको. तो देखो v कितना है 0, u कितना है 0, v कितना है 144 किलोमीटर पर आवर. Can you convert it into meter per second? Just multiplied by 5 by 18. Where this 5 by 18 comes from? We know that is 1 kilometer per hour means kilometer means 1000 meter, and hour becomes 3600 seconds, right? So we can just reduce these two zeros and cancel this by 2, so that we get this 2 5s are 10 and 18 2s are 36. So we get this 5 by 18 here. And remember 18 8s are 144. So we get this 8 5s are 40. So v is going to be 40 meter per second here. And if we replace it by that, then we get this 40 as it is divided by 2, and that is to be multiplied by time, which is already given here to be 20 seconds, right? And hence we can get this 20 multiplied here, so that we can cancel this 2 with 20, leaving behind 10, and this 40 multiplied by 10 becomes 400, which is going to be the final answer. That is B correct option. यहाँ पे हो गया. समझा ठीक से? No doubt we can also do it by this method, by finding the acceleration first, but it will just require time, because v is going to be 40 minus 0. So 40 minus 0 upon 20 comes out to be 2 here. So 2 meter per second square हमको acceleration मिल गया. And once we get the acceleration, we can use second kinematic equation here, that is x equal to ut plus half a t square, where u is going to be 0 again, and half into a, which is going to be 2 here, and that is multiplied by t square. T is here 20, right? So 20 का square क्या बनता है 400. Just these 2 gets cancelled, and we are left with 400 as a final answer. No doubt, it's okay. So again we are going to get the same answer 400 by using this method also. तो दोनों मेथड से हमको सेम ही आंसर मिल रहा है, नो डाउट. ठीक है, सो लेट अस स्टॉप हियर फॉर टुडे, कंटिन्यू द नेक्स्ट क्वेश्चंस टुमारो. ओके, नेक्स्ट लेक्चर में ये जो पार्ट है बेसिक ऑफ काइनेमेटिक्स वाला, वो ऑलमोस्ट खत्म हो जाएगा. So we can start with projectile motion, which is the second part in this chapter. Okay. Chalo, ठीक है. So let us stop. Thank you all of you. Bye bye.